All right, we're back. We're on page 2, notes 5 for Calc C. We're talking about the integral test, which we just learned. It says that if f of n is equal to a sub n, and f of x is positive, continuous, and decreasing eventually, if the improper integral from like 1 to infinity or whatever of f of x converges, then the series converges. If it diverges, the series diverges. Basically, they do the same thing. That's what I always remember. So the real key is knowing if you can apply the integral test. So here, I'm going to say f of x is 1 over x, natural log of x. And then I'm just going to say f of x is definitely continuous for x greater than or equal to 2. And I only need it to be greater than or equal to 2 because of here. So definitely continuous for x greater than or equal to 2. It's definitely positive because everything you're dealing with is positive. I'm also just going to assert that this is decreasing because the numerator is constant and the denominator is actually increasing. So you have a constant divided by something getting bigger, it's definitely overall going to get smaller. So for x greater than or equal to 2. So now we got to look at the definite integral. So the integral from 2 to infinity of 1 over x ln of x. Improper integrals have a lot of notation, and the notation is really important. It's like one of the things that gets looked at. So I'm going to say b is going to infinity, 2 to b. I use b because it's the upper bound. If it was the lower bound, I'd use a. If it was in the middle, I'd probably use c. But if it's really annoying when it's in the middle because you usually have to do like from the left and the right, and it's like, I mean, you still have to do it just because I think it's doesn't mean you don't have to do it. Limit as b approaches infinity of, so this is like a u substitution. If you let u equal the natural log of x, then du is 1 over x dx. So this is actually 1 over u du, which is the natural log of u. So this gives me the natural log of the natural log of x. Technically, it's the natural log of the absolute value of the natural log of x, but natural log of x is always positive on this interval, so I'm not really worried about that. Also, you know, look ahead a little bit and you can see this just diverges anyway, so we don't really need to worry about it. So equals limit as b approaches infinity of the natural log of b minus the natural log of the natural log of 2. But so as b approaches infinity, the natural log of b goes to infinity. So you're trying to find the natural log of infinity, which is infinity. So I'm going to say this is infinity, and therefore the series from 2 to infinity of 1 over n natural log of n diverges. So if you don't get a finite value for your improper integral, then the series diverges because the integral diverges. And by integral test. And there you go. So there's a lot of annoying things to remember. Like you have to remember to state and sometimes prove, if you're not really sure, that the function you're dealing with is positive, continuous, and decreasing. The decreasing part is the most annoying part because you need to take the derivative and it's just gross. Then you have to do the improper integral, which has all the notational requirements. So a lot going on. So let's see here. F of x is 1 over, I'm going to rewrite it as 1 plus x squared. And then this is definitely positive. It's definitely continuous. And it's definitely decreasing definitely for, I don't know why 6 is involved, but I'll say greater than or equal to 6, because that's, for whatever reason, that's where we're starting here. So now we just got to do the improper integral. So we're going to go with the integral from 6 to infinity of 1 over 1 plus x squared. I'm writing it that way because it's just, you know, as soon as I see that, I'm like Arctan. And hopefully that's something you look at and you think, oh, that's definitely Arctan, because it is. 1 plus x squared. Doing this in a weird order. Okay. Sometimes it's because I'm talking. Like try talking your way through a problem. It's not that easy. I feel like recording these videos has made me far less sympathetic to people who like to have a running conversation in class. Like, you are definitely not learning. All right, so we get the inverse tangent of b minus the inverse tangent of 6, which, like, I don't know what the inverse tangent of 6 is, but it doesn't really matter because I know that it exists. Also, so when you're faced with an arctan, you want to remember the graph of arctan is one of the more important graphs to know, and it has two horizontal asymptotes. One of them is at pi over 2, and one of them is at negative pi over 2. So if we're going to infinity, then we're going to get pi over 2. So this is going to be equal to pi over 2 minus the arctan of 6, which converges, right? Because that's a finite number. So since this is a finite number, we can say, therefore, the sum from 6 to infinity of 1 over n squared plus 1 converges by integral test. So it doesn't converge to pi over 2 minus arctan of 6. It just converges. Converges something like close to it, but we don't really need to know what it converges to. We just need to know, does it converge or does it not converge? So good for us, because who wants to do that? All right, this one I have a question about whether or not it's decreasing, and I really don't want to figure it out by hand, so I might just cheat and use a calculator on that part. So I will say that f of x is x squared plus 1 over x cubed plus 3x plus 2. I mean, you got to use the quotient rule, and even after using the quotient rule, are you going to be able to solve it? Like, who knows? It's got like a lot of quadratic parts. It's definitely positive. It's definitely continuous. So I'm going to go to the calculator and just let the calculator do the work. And then I'll come back and I'll just like state that it is or is not what we think it is. X cubed plus 3x plus 2. Derivative of the answer. Oh yeah, no. Derivative of, oh gosh, f of x. Here we go. So I want to solve answer less than 0 for x. Okay, so it's negative everywhere except at the zeros of the denominator, so definitely decreasing. So I'm just going to say that it is. It's one of those things, I don't know. Depends on your teacher. If you're allowed to use a calculator, then I guess you're allowed to do what I'm doing, in my class at least. If you are not allowed a calculator, I guess you're using the quotient rule. But we had the calculator, so we used it for. So I'm going to say for x greater than or equal to 1, because I don't remember what that said, but I thought that there was something happening at like 0.5-ish or something. So I'm just going to go from 1 to infinity, see if that converges. If that converges, then it would converge from 0 to infinity. So we'll do 0 to, nope, 1, literally just said I wasn't doing that. 1 to infinity of x squared plus 1 over x cubed plus 3x plus 2. So in my mind, I'm getting a little nervous about this integral because I'm like, what? But then I realized that I think a u substitution just knocks this right out. Like if you multiply the numerator by 3, I think you get the denominator, the derivative of the denominator. Ugh, so here we go. So this is going to be the limit as b approaches infinity of the 1/3, the natural log. Ah, God, I don't know what's going on. My hand just won't write. Here we go. 1/3, the natural log of the absolute value, technically, x cubed plus 3x plus 2 from 1 to b. All right, bleeding into my other problem here, though. So I'm gonna lasso and move it over. There we go. As if it never happened. All right, equals the limit. So we're gonna end up with a natural log of infinity again. So this diverges. The absolute value of b cubed plus 3b plus 2 minus the natural 1/3 the natural log. Why can't I remember that? Am I having an off day? Possibly. Plugging in 1, yet 1, 4, 6. This just equals infinity though, because the natural log of infinity is infinity. So this diverges. Therefore, the sum from 0 to infinity of n squared plus 1 over n cubed plus 3n plus 2 diverges by integral test. All right, let me zoom out and see how many problems we have to go. 1, 2. I mean, I feel like the next, I feel like the 4 at the bottom here are going to be pretty easy because they all look like reverse the power rule situations. So I'm going to stop here and say that we're like basically halfway through the page. Who even knows? I don't know. But anyway, I will be back in the next video to hopefully finish this page. So I will see you there.